G'day everyone, this is Hao-Mak Yangli, your Quantum Odyssey tour guide. Happy Independence Day 249, and we're only 1 year away from the milestone 250th Independence Day, the 250th anniversary of the United States, which is also the time of the three-nation FIFA 2026, which is going to be a dinky dive experience for all your soccer fans around the world, this time with 48 teams. So we only have like less than 1 year until this great countdown, the greatest, most beautiful sport ever. And on the morning of this day, just before 6 a.m. Eastern Time, the creator has rolled up a new game update 1.2.25. Again, the 25-ness, the 25 in the International Year of Quantum Science and Technology. But however, this is a relatively minor update. It just adds a few more puzzles and the re-explanation of the word sigil in this game. Not to mention that many of the Quantum Odyssey specific terms like descent, resonance, and convergence has been replaced with common terms like campaign, play ranked, and settings. And we will spin up our live stream for today. But again, once again, unfortunately, this is not the major update that will re-graphic the multi-qubit gates. Well, unfortunately, it's not the update that will re-graphic the multi-qubit gates that made the class. Unfortunately, this is not the update that will re-graphic the multi-qubit gates that causes the classical computation modules to be guesswork. So we will spin up our live stream. So I'm gonna wait. Okay, so this is a relatively minor update, and so far, 2 electrons has received updates in the form of new puzzles. And remember that top player Samaria Mulligan? Remember Mulliganatius, Ricardo Samaria Mulligan? He has also live streamed this update in response to the new puzzles. So I'm going to explain how each of these puzzles work. The first of the puzzles that has been updated is the SX module. So embrace the square root of x. So it's now 10 puzzles. So if you see, there are 5 puzzles which aren't complete, even though this electron is considered complete. Likewise, we have another updated electron, again a challenge electron between the orbitals, let's say p orbitals, d orbitals, namely the entanglement challenge, which also has 5 extra Okay, it has 3 extra puzzles. Your red entangled qubits. Unfortunately, I did not receive an optimizer gate, so I will revisit on this as well. So we will start with the square root of x. Okay, so now this one should be easy. So all you have to do is perform an H, and then perform. Okay, here's the thing: perform an SX on the second. So now this blue-yellow can be performed with an S. So to back to blue-green, and then we can perform the H's in parallel. So depth 2. This one looks a little bit intimidating, but this is nothing more than X, an X on the ground. So it sends the qubit sigil. Okay, so this sigil, there's a color change, which is, but then the HZH, this is nothing more than an X. So here's a solution to this puzzle. We add a we add a Z and we add an SX to see what is the pattern. The next one is straightforward. So there is an X, add an X, but you can also add a Y to advance the phase as well. Then we perform an SX. Okay, so now we have these two opposing colors. The blue-green can be turned into blue-yellow through an S on the first, and then on the right half we can apply another blue-green to make the blue-yellow, only on the right half. So okay, this one is nothing more than a variation of a GHZ. So we can do an SX instead of an H. SX, then we have control Y and X. The Y is there to advance the phase. Because blue-yellow advanced by a quarter turn becomes blue-green. Okay, this one is another GHZ variant. So we perform an H, but instead of an CXX, we perform C root X root X. The result is actually okay, the result is two opposing Y basis eigenstates. Namely, we have the Y advanced by a quarter turn, and then this is a plain old left state. So left state advanced and the left state. Now I'm on bracket 10. We now revisit the entanglement challenge. We revisit the new puzzles before we revisit on the puzzle I did not optimize. So here we have blue and red, but this is nothing more than a GHZ. So it's H, then GHZ. We completely ignore the right half. And here's my optimizer key. This one, it says these superpositions are not entangled. Here's the thing. We can ignore the ground qubits. So we have 0, 0, 0, then we have 1, 1, 1. Well, it is actually entangled. It's nothing more than the GHZ state again. So we have this. H, parallel to that, it's going to be H, control, XX. Okay, the last one, it says, even if they would, how could you tell? So notice the left half, only the slots on the left pair between adjacent pairs have the sigils. While on the right half, only the right member of each adjacent pair have the sigils. So what is the state? To perform the non-entangled part, which is the for equally spaced per half, we just add a H and another H on the first and second. We then split this again in parallel, and only on the right half we add an X on the ground. So here's the brilliant solution. Let's continue. So 4 red entangled qubits. This is the one which I missed. So there is an obvious answer to that. So the obvious answer, so we could try this. H, then H, then Z. Okay, so we need to make it red. So this thing should be red. So let's go with X, Z. Okay, this is where the split can happen. H. This is where you can perform the GHZ. So there are 8 gates, but most of the solution has only 3 gates. So I do suspect that this puzzle has been changed. In fact, you cannot do this in 3 gates. You cannot simply perform a 4-qubit GHZ in 3 gates. So I have to say this puzzle has been changed.